Today we're going to solve square root and other radical equations. To solve radical equations, you want to isolate the radical and then raise each side to the power indicated by the index. So, if you want to find the solution of the square root of 4x plus 1 minus 5 equals 0, we're trying to isolate the radical. So first thing we want to do is add 5 to both sides. So we have the square root of 4x plus 1 equals 5. And then you want to square both sides. So we're going to square the left and square the right. When you square the square root of 4x plus 1, you get 4x plus 1. When you square 5, you get 25. So then we just solve like we normally would. So 4x equals 24. Divide by 4, x equals 6. How do you check your answer? You would plug x value into original equation. So if I wanted to check this, I would just take my x equals 6 and plug it in for x. So 4 times 6 plus 1 minus 5 equals 0. Square root of 25 minus 5 equals 0. 5 minus 5 equals 0. Check. Do you have to check your answer? The answer is sometimes. And I will explain when we do need to check our answers. So if we want to solve these, okay, first one, you're going to add 1 first. Again, you're isolating the radical. Now we divide by 4. So square root of x equals 1. We square both sides. X equals 1. Here, it's already isolated, so we square both sides. 3x plus 4 equals 16. Minus 4. 3x equals 12. Divide by 3. X equals 4. And then the last one we have to isolate, so add 7. So square root of 2x plus 3 equals 7. And then we square both sides. So 2x plus 3 equals 49 minus 3. 2x equals 46. Divide by 2. X equals 23. Okay, so what are the solutions of these? Well, the only thing we need to remember, I'm going to put a little asterisk up here. Even index gives plus or minus. So when you have an even index, like the square root or the fourth root or something, you have plus or minus. So if we look at this original problem, we want to isolate the radical. So in this case, you want to isolate the x plus 3 because that's getting raised to a rational exponent, which can be rewritten as a radical. So you're going to divide everything by 2. So x plus 3 to the 2/3 equals 4. So now we're going to raise both sides to the 3/2. So you're raising it to the reciprocal. So that way 2/3 times 3/2 is going to cancel out, and you have just x plus 3. Now 4 to the 3/2, we can rewrite that. And since we know that we can simplify this outside in, that's really going to be 2 to the 3rd, which is going to be 8. Now, when you take the square root of 4, that's really plus or minus 2. So when you raise it to the 3rd, you get plus or minus 8. So that's where this asterisk at the top gets brought in. So if you're taking the square root of something, you get plus or minus. So when we go to solve this, x plus 3 equals plus or minus 8. So we have two options here. We have x plus 3 equals 8, and in that case, x equals 5. Or x plus 3 equals negative 8. In that case, x equals negative 11. So you could get more than one answer. If we look at the next one, again, isolate. So we're going to divide by 3 first. So we have x minus 2 to the 3/4 equals 8. And now we're going to raise both sides to the 4/3. So now we just have x minus 2, since these cancel out. And now 8 to the 4/3, we can rewrite it like this. So the cubed root of 8 is 2, and then 2 to the 4th is going to be 16. So we have x minus 2 equals 16. Add the 2 over, x equals 18. We don't have plus or minus in this one since the index is odd and not even. So if we look at this one, we're going to raise both sides to the 3/2. So we have just x plus 5 on the left. And now 4 to the 3rd, and then the square root of that. So since we're taking the square root of 4, that's going to be plus or minus 2. And raised to the 3rd, so plus or minus 8. So x plus 5 equals plus or minus 8. So x plus 5 equals 8. X equals 3. X plus 5 equals negative 8. X equals negative 13. In the second one, we're going to add 2 first. So x plus 1 to the 3/2 equals 27. And now we're going to raise it to the 2/3. So x plus 1, these are gone, equals, now 27 to the 2/3, we're going to rewrite it as 27 squared and the cubed root. So the cubed root of 27 is going to be 3, and then squared is 9. So x plus 1 equals 9. There's no plus or minus since the index is odd, and now x equals 8. Now if we look at this one, first thing we have to do is, again, isolate the radical. So we're going to subtract 3. So now we have the square root of 5x minus 1 equals x minus 3. And then we're going to square both sides. So we end up with 5x minus 1. And then we're squaring x minus 3. So we actually have to write x minus 3 2 times and FOIL it out. So when we FOIL that out, we're going to get x squared minus 6x plus 9. So now we have a quadratic, and we want to get everything on to one side and set this equal to 0. So we're going to minus 5x and add 1, minus 5x and add 1. So now we have x squared minus 11x plus 10 equals 0. And then we're going to factor this. So multiplies to 10 adds to negative 11. We're going to use negative 10 and negative 1. When we go to solve this, we get 10 and we get 1. And then it says to check your results. So let's do a check. We got to check each answer. So if we're checking 10, we're going to plug in 10 for x. So square root of 50 minus 1, so 49 plus 3. Whenever you're doing your checks, the square root is always going to end up being positive. So the square root of 49 is 7. Even though it's plus or minus 7, when we're doing checking, it's always going to be positive. So 7 plus 3 is 10, so that checks out. And then our other check we're going to do 5 times 1 minus 1 plus 3 equals 1. So the square root of 4 plus 3 equals 1. So 2 plus 3 is not equal to 1. So x equals 1 is not an answer, and x equals 10 is an answer. So when should you check for extraneous solutions? So remember, extraneous solutions means that the original answer that you get, the answer that you get is not true for the original problem. So when you plug it into the original problem, it'll come out to be false. So when do you have to check for them? When there are variables on both sides of the equal sign, and you get 2 answers. So basically, it is the intersection on the graph. So if you were to graph this original problem, like the square root of 5x minus 1 plus 3, and then you were to graph x, where they intersect would be our answer. So if we look at this additional example here, everything's already isolated the radical, so we just are going to square both sides. Make sure that we write x plus 3 twice and FOIL it. You can't just distribute the square. So this is going to give us negative 3x minus 5 equals x squared plus 6x plus 9. Bring everything to one side, so add 3x and the 5. Add 3x and 5. X squared plus 9x plus 14 equals 0. Multiplies to 14 and adds to 9. We're going to use 7 and 2. So when we solve this, we get negative 7 and negative 2. And now we have to check. So since there was variables on both sides, and we got 2 answers, we need to check this. So the square root of negative 3 times negative 7 minus 5 equals negative 7 plus 3. So 21 minus 5 is going to give us 16. And this is going to give us negative 4. So even though the square root of 16 is plus or minus 4, every time we're doing a check, we can't have the negative version. So that is not going to be true. And why it can't be that way, we'll go into in the next lesson. But for right now, whenever you're doing your checks, it has to be positive. So now we have negative 3 times negative 2 minus 5 equals negative 2 plus 3. So we're going to get 6 minus 5, which is 1. So 1 equals 1, check. So x equals negative 2 is correct. Negative 7 is not correct. It's extraneous.